In this video, we're going to learn our fourth and final method for solving quadratic equations, solving using something called the quadratic formula. But before we do that, we're going to do a hardcore review of solving by completing the square. So we're going to solve the following equation by completing the square. Ax squared plus bx plus c equal to 0. Now with this equation, we've gotten rid of all the numbers for the coefficients and replaced them with letters. But the process for completing the square would remain the same. So as I go through this, make sure you're seeing the completing the square process as I work. So for example, first we would start by subtracting our constant, in this case c, from both sides of the equation. That gives me ax squared plus bx equal to a negative c. And then the next thing we would do is divide off whatever coefficient the x squared has. In this case, that's the a. So I'm going to divide both sides by the a. And that's going to give me x squared plus b over a x equal to negative c over a. Now that's our basic setup for completing the square. Actually, at this point, we usually have our fill in the blank. So maybe putting those blanks in there will help you see our setup. So our basic setup is to get the constant on the right and have our leading coefficient be a 1. So we got it all set up. And then this is the point where we took our number that was in front of x, we divided it by 2 and squared it. So I'm going to do that over to the side. I'm going to take the number in front of x, which is b over a. I'm going to divide it by 2, but I'm going to express that as multiplication by a half. That equals b over 2a. And then I'm going to square that result. So that's going to mean squaring all of the factors inside of there. So I get b squared over 4a squared. That is the magic number that I add into both sides of my equation. So I add b squared plus 4 over a squared to both sides of the equation. Once I do that, I know how the left side will factor. It's going to factor as x plus b over 2a quantity squared. And I know that because I designed it to do so. That's what the completing the square process is. So essentially what it is that we're adding to x inside of the parentheses is what we had when we were finding our magic number to add in. It's what we had before we squared it. Now to calculate what we have on the right side, we're going to need to add these two fractions. In order to add those, I need to find a common denominator. I'm going to do that work over to the side as well. So first I need to recognize that my least common denominator here is 4a squared. This guy has the 4a squared. We need to get it so that the first fraction has the 4a squared. In order to get it so it has the 4a squared, we need to multiply in a 4a over 4a. And then we can just add on the second term because it already has the LCD. So that gives us a common denominator. Once our denominators are the same, we do the math across the numerator. That's going to give me a negative 4ac, just rearranging the letters there alphabetically, plus b squared, all over my LCD of 4a squared. So this is what my right side of my equation combines to when I add those two fractions. All right, once I get those combined, now at this point in the completing the square process, this is where we take the square root of both sides of the equation because we have completed the square. So now we can use our square root property. So I take the square root of both sides, being careful to remember to add in my plus or minus. So when I square root the left side, I'm just going to end up with what's inside the parentheses because the square root and the square cancel each other out. Now on the right, I can't simplify the numerator under the radical because there are two separate terms there, and we can't apply a radical to individual terms. However, I can simplify the denominator. And both of those are perfect squares, so I can square root the denominator, making that a 2a. So that gives me on the top just the radical plus or minus the square root of b squared minus 4ac, and I just switched those terms around so that the leading coefficient was positive. and then all of that outside the radical is over 2a. At this point, what I need to do is subtract the b over 2a from both sides to get x by itself. Okay, so I brought that up to the top to give myself a little bit of room. I'm subtracting the b over 2a from both sides. That's going to cancel out and leave me with just an x on the right. And on the left, I'm going to have my b, my negative b over 2a plus or minus the square root of b squared minus 4ac. And then that's over 2a. Now, are my two fractions, as ugly as they at least have a common denominator. So I can, if I wanted to, go ahead and combine that and express it all over one denominator. And that gives me that x equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. So I just combine my fractions to be over one common denominator. Now some of you guys may have seen this before. What this result is what's called the quadratic formula, which is what we're learning about in this section, is to solve using the quadratic formula. So essentially the quadratic formula comes from completing the square on a generic quadratic equation, where instead of numeric coefficients for a, b, and c, we just use abstract ones as letters. That means that anything that can be solved by completing the square, we can use the quadratic formula for. And since completing the square can solve any quadratic equation, that means the quadratic formula can solve any quadratic equation. So I'll go ahead and clear this out and state the quadratic formula formally. So the quadratic formula is for where ax squared plus bx plus c, where we can't let a equal to 0, we have that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now the reason why we can't let a equal to 0 is if we let that equal 0, then this whole term would zero out and it'd be gone, which would mean that it wasn't quadratic. It would be linear if a equals 0. Alright, now that we see what the quadratic formula is, let's do a couple of examples so you can see how it works. Alright, solve using the quadratic formula. 3x squared minus 6x plus 3 equal to 2x squared plus 6. Now when the quadratic formula was developed, we started with ax squared plus bx plus c equal to 0, and that defined our a, b, and c. So in order to use the quadratic formula, we first have to start by putting whatever quadratic equation we're dealing with into this standard form. So in this case, that means I need to subtract 2x squared from both sides, and I need to subtract 6 from both sides. Once it's in standard form, and not until it's in standard form, I can identify my a, b, and c. Here my a is a 1, because when there's not an explicit coefficient written in there, it's a 1. My b is a negative 6, and my c is a negative 3. So what I'm going to do is take my quadratic formula and plug that information in for a, b, and c. Now one good thing to do before you start plugging things into the quadratic formula is to write it generically. This will help you memorize it, and it will also give you a clean template to work from. So I'm going to plug A into all the A's, plug B into all the B's, and plug C into the C. Alright, I've got all those plugged in, and I color coordinated it to help you see where stuff was coming from and going to. Go ahead and take a second to make sure you track with all of that before going on. One of the things I want to emphasize is that we have a negative in the formula for our b, and that's this negative out here. We also have our b has a negative value, and that's that negative there. Basically, you can think of that negative b out front as the opposite of b. So whatever sign b is, this will end up being the opposite, because when I simplify this, I'm going to get a 6. And that's what we'll do now. Once you get everything plugged in, it's just a matter of simplifying what's there. So on the top, I have 6 plus or minus the square root of 36 plus 12. On the bottom, I just have a 2. I also want to caution you about this sign here. It's probably the most common mistake when simplifying the quadratic formula is getting that sign wrong. What I do is I take and look at my 3 numbers here and I multiply them without concern of sign. So it's a 4, a 1, and a 3. That multiplies to be a 12. So I know it's going to be a 12. And then I just count up the number of negative signs. So here I have 2 negative signs. 2 negatives make a positive. So that's how I process through that. I process the numbers and the signs separately. So go ahead and combining those gives me 6 plus or minus the square root of 48 over 2. As I go on, I'm just going to bring this over here. Now the square root of 48 doesn't square root perfectly, so we're going to have to just do what we can with that. So it simplifies to 4 square roots of 3. And then at this point, I'm going to distribute my 2 into both of the terms in the numerator, giving me that x equals 3 plus or minus 2 square roots of 3. And that's going to be my final answer. So that's the idea. Basically, you get your equation in standard form, then you plug it into your quadratic formula, and then you simplify that as much as possible. The simplifying process with the quadratic formula can be tricky, and students can get frustrated because they're getting it wrong, because they're losing themselves in the simplifying process. But I assure you, the more you practice it, the more you'll learn not to fall into the potholes that are possible with that. Let's do one more example, and then I'll give you a chance to try some yourself. Alright, so we're going to solve using the quadratic formula on 2x times the quantity x minus 9 equal to 4 plus 2x. So again, we want to start by putting this in standard form. The first thing we need to do is to distribute out our multiplication so we can get stuff expressed in terms. That gives us 2x squared minus 18x. And then we want to get stuff equal to 0. So I'll subtract the 4 from both sides, subtract the 2x from both sides. Alright, so that gives us 2x squared minus 20x minus 4 equal to 0. Now, with this example, I want to show you something that is an option for you guys. If you notice, this polynomial has a GCF of 2. Now, if you want to plug in an a of 2, a b of negative 20, and a c of negative 4, you can, and you'll get the right answer. But another option for you is you can go through and divide out that common factor. In other words, divide both sides by a 2. And when you do this, it's going to reduce all these values. So we get x squared minus 10x minus 2 equal to 0. So it reduces it all, it's still equal to 0. And now we can go with our a equaling a 1, our b equaling a negative 10, and our c equaling a negative 2. We'll get the same answer either way because that extra 2 will end up dividing out or reducing in the last step when we simplify the quadratic formula. Alright, so we want to plug those things into the quadratic formula. Remember, it's a good idea to write it generically. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then that's what I'm going to plug my letters into. I'm going to go up top to do so. Alright, that gives me this. Go ahead and take a second and verify that you're agreeing with all my placements on that. You can pause the video and then go on once you're sure we're in agreement. So simplifying that gives me that x equals 10 plus or minus the square root of 8 over 2. And then the square root of 108 simplifies to 6 square roots of 3. And again, with this example, we can reduce that 2 or distribute the division. This won't always be possible, but when those all reduce by the same amount, you want to go ahead and distribute that distribution. So our final answer is x equals 5 plus or minus 3 square roots of 3. All right, go ahead and give some of these a try and see how you fare.